Ownership rules and drop. 3 rules, memorize them. Rule number 1: each value has an owner. Every piece of data is owned by exactly one variable. No ambiguity. Rule number 2: only one owner at a time. You can't have 2 variables owning the same heap data simultaneously. This prevents double free errors entirely. Rule number 3: drop on scope exit. When the owner goes out of scope, the value is dropped. Rust automatically calls a cleanup function that frees the memory. No garbage collector needed. Just the closing brace. Look at the code. We create S. We use it. The scope closes. Drop. Drop is called memory freed immediately, 0 overhead. Let's see it in action. Fn main. So we're creating a variable let s1, which is going to be type string equal string from. So we're getting a string, and we're simply going to call it hello. Now here's where the magic starts. We're creating another variable called s2, and s2 equal s1. In this case, the ownership moves from s1 to s2. Now s2 is the new owner. Now we know that s2 is the new owner, but let's try to print s1 and see what's going to happen. So print So now, based on what we learned, we're assuming that the ownership has moved from the ownership of that variable has moved from s1 to s2. But here we're trying to print s1. As expected, we have an error. So let's have a look in that error. Here we see move occur because s1 has a type string which does not implement the copy trait. So we didn't copy, we just move a value from s1 to s2, and we borrowed. So there's another way that we can do to solve this problem. We can clone it like it's happening here, or we can also borrow it. So let's go back and do s2 because the new owner. Now it should work. As you can see down here, hello is printed out. But why does this happen? Because if both s1 and s2 tried to free the same heap memory when they went out of scope, you'd have a double free. A classic C bug, by the way. Rust makes it impossible at compile time. The same rules applies when passing two functions. Calling take moves s into the function. So when take returns, s is dropped. You can no longer use it in main. So let's try to do that here. So we're trying to print s, but we've learned that take has taken s, but here we're trying to print s. What's going to happen? Let's view our terminal. And voila, a move occurred because s has type string, which does not implement the copy trait. The value moved here, so it moved to take, to this function. So this is what happened. We could have cloned it and we could have copied it, but we didn't do that. That's why we're having this error. So I hope this makes sense, and the best way for you to understand is actually copy this code and run it yourself and play around with it. So here is a key concept. Passing a variable to a function moves ownership unless the type implements copy. So what's copy? The copy trait stack only types are simple types like integers, floats, booleans, and chars, and these are cheap to copy. There's just a handful of bytes on the stack. When you assign or pass these, Rust just copies the bits. The original stays valid. Let x equal 5 and let y equal x. Both x and y are usable. Now let's move on to move semantics. Heap owning types. Types that own heap memory like string and vec do not implement copy. Assignment moves ownership. The golden rule: if a type implements copy, assignment copies bits. If it doesn't, it moves ownership. That's it. Now let's try deep copying with clone. Let's see that in action. Let s1 equal string. So we have a string here. Let s2 equal, we want it to have the same value as s1. So what we do here, to clone, we just type s1 dot clone. Now the heap data is duplicated explicitly. So now both values s1 and s2 are valid because there was no move in ownership, and s2 is just a duplicate of s1. So let's print it here. So we're expecting the same string to print. So it's going to be a hello hello. So as we see here, a hello hello, as we expected. Now let's clear this. So if you generally need two own copies of heap data, call .clone. This explicitly duplicates the heap allocations. Both variables are valid. The performance note. .clone allocate new memory on the heap. It's expensive. If you just need read access, prefer borrowing instead of cloning. That's what we're gonna do in the next section.